Okay, welcome everybody. We will start in a second. The presentation is going to be recorded, so we will send slides and recording after the webinar. Okay, I think we can start. So once again, hi everybody. Today with you, it's me, Alexander Zaitsev. I'm co-founder and CTO of Altinity, and I work with ClickHouse since 2016. And with me, here is Mikhail Filimonov, who is our principal ClickHouse engineer in Altinity, and also works with ClickHouse and especially ClickHouse performance for I don't know, 7 years or something like that.
Hey guys.
Yeah, so the performance is very difficult topic. We'll try to get deeper in some areas and just scratch the surface on some others. But I think it's going to be interesting for everybody. So a couple of introductions. You know, Altinity, I hope we are database geeks. We love databases, we love ClickHouse, and we love developing high-performance applications with ClickHouse. And this webinar is mostly for developers who work with ClickHouse and want to understand how to optimize the performance, maybe for DBAs as well. Our goal is just to give you some tools and machinery that you can use later on with your own applications in order to troubleshoot performance and improve performance of your ClickHouse applications and queries. So let's start with just the wrap up. What is ClickHouse? This is, first of all, this is SQL database. So it talks with SQL, and we will use a lot of SQL examples today. It runs everywhere, starting from a laptop to the huge cloud providers on bare metal, on any virtualization systems. So you can run it on Android iPhone if you want. It doesn't make a lot of sense, but it's possible. It uses shared nothing architecture, which drives a lot of performance characteristics, both in terms of a single node and the cluster itself. It is columnar, which is also very important. And you can see the ClickHouse logo is actually resembles columns a little bit. Internally, it also uses a lot of different kinds of optimizations, including vectorized execution. So this is very, very low level. Then a lot of different algorithmic optimizations, a lot of parallelization on all levels, and it tries to be as fast as possible for every single query. And of course, it scales to many petabytes. Today, we'll be mostly working with it just somewhat small examples, but we have seen installations of a huge scale, and performance problems, they are typical for any size ClickHouse system. You can hit it on a small application and also on a huge cluster. And of course, ClickHouse is open source. This is very important, and you can use it without any license fees. You can modify the code and embed it to your applications. So let's start about let's talk about performance. You know that ClickHouse is very fast. ClickHouse не тормозит in Russian is one of the famous ClickHouse slogans, but sometimes it may go slow in certain cases. And the definition of slowness might be very different depending on a different use case or your view on your performance. What does slow mean? Does it mean that the single query is slow? Does it mean that you have a lot of multiple concurrent queries and a system becomes slow and unresponsive under the load? Do you use a single node ClickHouse or a cluster? So maybe your query is very fast on a single node, but once you go to a cluster, it starts to be slow. Do you mean the data latency by slow? So it's slow to insert, not a query. And by definition of slow and performance, what do you mean? Is it a maximum time, some median, some percentile? This is very important questions that you need to ask yourself, before you try to optimize anything. But usually, when somebody means my ClickHouse is slow, this is there is some particular query, and this particular query requires some attention or optimization. When we're talking about the query itself, and if it is slow, it means that there is some bottleneck in the query. But what is this bottleneck? It could be I/O, and this is the most typical case in databases for decades, because databases, they are data intensive, and the I/O is often a bottleneck. But it could be also CPU if you have a lot of computations. It could be RAM if your query needs to do a lot of manipulations in memory, like joins or aggregations. It could be network if your query has to read a lot of data over the network. It could be some background operations that may affect your cluster, and it just becomes slower, and that affect your particular query. Or if we are talking about ClickHouse and replication, it could be Zookeeper that slows down your insert operations and saturates the cluster. How do you know what is a bottleneck? What is what tools can you use in order to find the bottleneck and optimize that? So let's start with a single query optimization, because usually this is the most simple thing to optimize. And the plan of attack is very simple. First, we need to find the slow query, and we'll tell you how you can do it. Then you need to understand what is a bottleneck. If it is a query itself is slow, or it is slow because there are some other workloads that slow it down. And finally, you need to understand inside the query or what slows it down. It could be the query reads a lot of data, or it could be the query has to process the data, and it probably does it inefficiently. Once you understand the reason of the slowness, you can optimize. And what tools you have in order to tune your queries and understand what's going on? First and foremost, this is benchmarks. So you always need to benchmark your query. You need to compare the query before and after optimizations. And this is the only way to understand if you're making the progress or not. ClickHouse has a very convenient query log where you can find the query times. You can easily use query log in order to find the slow query. And in addition to just query times and memory usage, it also exposes profile events, which records a lot of internal metrics about what was happening during the query execution. For example, how many files has been opened, how much data has been read from the disk, and so on and so forth. In addition to profile events in the query log, there are some log tables like metric log, asynchronous metric log that allow you to see the cluster, ClickHouse cluster or ClickHouse server statistics as a time, and probably use it for monitoring, for time series, and so on and so forth. This is also very important. So you usually operate your ClickHouse server or cluster as a part of some bigger infrastructure, and having proper monitoring allows you to see and detect changes in the cluster behavior, and also see the effect of any optimizations. So using the metric log, you can see that your cluster is inefficient because it runs a lot of operations that normally you shouldn't do. And after optimization, you may find that your metrics are much better, and this is the goal. Also, there is an explain statement that can be used for the particular query, and ClickHouse has several different kinds of explain statements that show you different things about the query planning, the query execution, the query estimates, and we will show you a couple of examples. And finally, there are logs, and there is ClickHouse log, which you can look into the file system. And you can also enable log in ClickHouse client using log level trace as a command, set log level trace in ClickHouse client, and that will print you log for any query that you are executing using ClickHouse client. This is also a very convenient tool for query performance analysis. And for ultimate gigs, there is a trace log, which allows you to map the query execution to the internal system calls in ClickHouse code itself, and at the end see which internal ClickHouse functions has been executed how many times, and that will also help you to find bottlenecks. But this is for very, very, very advanced users. Let me say this. It is very essential, I already mentioned that, do benchmarks and do benchmarks on the real data, because we often hear from our users that the query works fine on staging, but once they go to the prod, it doesn't work or work very slow. It's important to understand that you have the same data in your test staging environment in production. If the data size is different, then your performance metrics will be different. It is also important to benchmark if the particular query is slow for every run or just sometimes, because it may be fast in certain cases and slow in others, and it may be a reason of some other process which is running on your production cluster. So all operations that are running together with queries may affect performance. So when you're doing some profiling, you need to make sure that there are no mergers or the merge level is the same. There are no very heavy mutations that may saturate your disk. There are no backups running that may saturate disk and network, and so on and so forth. There are some tools to simplify the testing. ClickHouse Benchmark, which is part of ClickHouse distribution, is one of them. It allows you to run a single query or multiple queries in a loop with multi-threading if necessary, and generate a workload to your test system. Don't use it in production, only in a test and staging, because it may actually produce very high load. So here I can pass the stage to Mikhail, and he will guide you through the query for single query optimization. Mikhail, welcome.
Yeah, hi guys. Yeah, so when we start talking about, when we start looking on particular queries, we need to look on, we can look on different aspects of that. Like there are very basic statistics, like the most obvious one is execution speed, like the memory it uses, how much bytes it read, and so on. So all those basic stats is actually it's printed in ClickHouse client with every time you run every query. And there are even more detailed information about the query execution, which you can find in the profile events in the query log. But you can, like, if you like to see them, like for example, sometimes when I play with some queries, I just rerun like several variants of the same query in the ClickHouse client. And sometimes I would like to see those profile events just once I rerun it every time. And actually, ClickHouse client allows you to output those things too. So just there are some flags you can pass, as in that example, and every query execution will show the profile events created by that. So for example, here we see that query was it spent like 100 user time microseconds, like 100 microseconds of a CPU user time. It was very simple query, but so it doesn't spend so much. But yeah, we can go to the next one. Yeah, so also we can, like, once we know that there are those metrics, like which are stored in the profile events or in basic fields in the query log, we can use them to compare different, for example, two different queries. So for example, if you have two query IDs which run, which it can be the same query, which just, I don't know, like runs once it works fast, another time it works slow, or it can be two different variants of the same query. So if it is like if you're playing with trying to understand how different variants of a query behaves, you can use that query to compare those two runs. So for example, here is the output of that query. We run the same query twice, and first time it was really fast. And the second time, first time, sorry, it was very slow. It was about like 3 seconds. And the next time it was like 0.1 second. And by running that, and it was exactly the same query. And now if we start looking on those, on the result of output of that query, we can see that actually that query, like the first one, had about 300 mark cache misses. So it means that it read more marks from it used to read more marks from a disk, while the second one had everything was in mark cache hits. So like mark cache did help here the next run. And we see also how big the impact was here. Like it spent like 31 million of microseconds in the first time to just waiting for those marks to be loaded. So actually here is the example why it helps to understand why the query was slower. And additionally, we see some other metrics with changes. And for example, it's we clearly see that the query was using disk S3. And the first query was reading some data from the disk S3, while the second one didn't do that. So most probably we can also guess what was happening by knowing that it was mark cache. So it was to read those mark files from the disk, to load those marks which were missing in the cache. It used to run to load them from the disk S3. That's why it was so much slower first run. Second run, it had the data in the mark cache and it was faster. So this the same way you can compare the same query or two different queries. It's very helpful to understand what's happening. The same technique can be used for comparing the query logs, not for two concrete queries, but for comparing two intervals. So for example, if you know that during 1 hour the system was behaving good, during the next hour it was working bad. You can just compare those 2 hours using that query, and it will show you query by query. Like for example, how many of those queries you have before and after, like how much, I don't know, like disk read it had before and how much disk read it had after. And also the same technique can be used when you test some setting adjustments. So for example, I don't know, like as an experiment, I want to increase the max threads or decrease max threads, like how it will impact my system. So I can just try to change that and compare afterward, like later on, what was the impact, and have a breakdown by particular queries. Yeah, so usually when I look for some problems or some problematic queries, like when I need to find like what is slow, I actually start from understanding what is the problem in the system. So usually just by looking on the system metrics, which can be provided by, I don't know, by Prometheus, by some commercial tools, by Zabbix, or by embedded ClickHouse tools like Metric Log and so on. So just by looking on the global system metrics, you can see, oh, my CPU usage is like 100%, or you can see that my disk throughput is very high, or you see, I don't know, like it's often goes out of memory and so on. So you can identify by looking on those basic monitoring tools. You can understand what is bad, where is your bottleneck. And here is a table which helps you to map those bottlenecks in the system to the particular fields or profile events in the query log. So for example, what CPU usage it's directly mapping to the profile event, which is called OS CPU virtual time microseconds. Disk throughput, it's mostly about read and write bytes. Network, again, read and write bytes. RAM, obviously, memory usage, and so on. So actually, once you see and maybe the only exception here is that load average, it is a bit more indirect way of finding them. So if you see that CPU usage is low, but the load average is high, it means that actually not a particular query is a problem, but the number of queries can be the problem, or number of threads. How can we use that information? So usually after identify that, okay, we have the problem with the CPU, which like CPU usage is 100%. I can do the query like that. So just it query reads the data from the query log cluster wide, and it groups all the queries there by the field which is called normalized query hash. That field allows you to, so it actually removes all the constants or from where conditions, remove all the exact numbers, exact strings, and so on from that. And after that, it creates some kind of normalized query. And after that, from that normalized query, it calculates a hash. It's very handy to group the queries by that field. So now we can group the similar queries. So for example, sometimes it could be a single query which executed once, which create a problem, or it could be like one query which executes every single execution is very fast, but the number of those queries is very high. And once you group by those by that normalized query hash, you can see you can compare both. So you'll see all together like the query which were executed once and burned, I don't know, like 1 hour of CPU time, together with a query which were executed 1 million times, and it burned again like 1 hour of CPU time. And you can consider like what are the options, like which one should I spend time on trying to optimize that. Yeah, and obviously it also have some general fields like where event time between and so on. If you follow the link on the slide, you can find even more complex examples which tries to collect all the metrics all together. Yeah, but actually one of the before going very deep, like what you need to start looking at first. So before you'll go too deep into that, before you'll start, I don't know, analyzing all the profile events and so on. Usually one of the main metrics, one of the main problems you can have with queries is the IO. So it is like super typical. Like if some query is slow, most probably it's just not the optimal from the IO perspective. So it means that it either read too much data, either it read it's very slow or something like that. So good queries usually they don't read too many gigabytes, too many terabytes, and so on, and read them fast, like with a good speed, like more than usually more than few gigabytes per second. But yeah, you can use that like if it's more than 1 gigabyte, it's tolerable. Yeah, so here, for example, there is like this same variant of the query was executed, like it is like the same query rewritten, and if you just run that query in the ClickHouse client, like after every run, it outputs the main statistics. You can see that the first query was executed in 4 seconds. It processed 2 billion records and was reading 28 gigabytes. With a speed 7 gigabyte per second, the last chunk of that. The next query, actually, it is the same query. It was just I didn't provide them, but it was some synthetic queries which do counts like in different ways. The second query was still processed like 2.5 billion rows, but see, it read much more data from a disk. So actually the difference was that it was reading, the first one was reading a single column, while the first one was reading all the columns. And here it read almost a terabyte of data. And obviously that is very slow, so it spent like 160 seconds to finish. And the third one, while it still read as like the same amount of data as the first one, so it was like still 30 gigabyte of the data,
but this query, like the read speed was very poor. So it was not 7 GB per second, but it was 100 MB per second. And it was even slower than the second one. Why it happened? Because actually I synthetically, like to create that example, I just synthetically create the column which is compressed very aggressively. So if your query reads a lot of data, so if you have too much of I/O, what can be the problem? Most probably the query is just doing the full scan. Sometimes it's easy to like people, especially people who start using ClickHouse, they often do the full scans without being aware of that. So ClickHouse is just so good in full scans that you sometimes, especially once you run on a synthetic data on the staging, you just don't feel that it's like it scans a million rows and there is some problem there. But once the data starts to grow in production, it starts being the problem. So doing full scans is not the option. You just need to use some indexes. And how you can see what is happening. You can use few variants of explain statement, explain indexes and explain estimate. We'll show like it in next slides, which help you to see what's happening, like how much data from what is the subset of data it plans to read. The same data is printed in the logs. Like if you like to read logs, you can just do like send logs level to debug, and that will, or to trace, and it like one of the lines will show how much rows it plan to read. And there are some flags which you can just toggle to see if your query uses a primary key. So for example, if you'll just toggle a flag which is called force primary key, and your query start failing after that, it means that your query was not using the primary key, which is very bad. If you toggle force index by date, actually that's quite an unfortunate name. It's the partition key index. So if you toggle that flag on and your query start failing, it means that you don't have any conditions by your partition keys, and so on. So like for skipping indexes from projections and so on. Yeah, and also like you need to know some ClickHouse some ClickHouse specific things. Like it is super typical problem with performance is then people actually coming from other databases which are familiar with SQL syntax, they do queries like below. And the query like that table here, it can be indexed by date and partitioned by date also, but that query will be doing the full scan. Probably I mean not asking the you guys why, but if you, I don't know, like give you a few seconds for thinking about why it's happening. 1, 2, 3, and the answer is the aliasing. Actually, ClickHouse is allows you to redefine the aliases everywhere. So actually, that alias actually there is some mistake here. An example, it should be toString number, toString date as date. So like once the date is like, if the date is the real column in the table, when you do the where date equals something, you expect that it will be reading, that it will be using that date as the like you'll use the column for doing the filtering. But if you redefine that date as the you'll create another alias there. It will be using that alias in where conditions. So instead of using that cheap expression where date equals something, we're comparing the exact field using indexes and so on. It will first do like toString date and create that another column called date, and we'll be using the conditions on that. What else? There is like explain indexes. Explain indexes. It allows you to see how ClickHouse sees your query. So
what was the conditions extracted from that, and how they are transformed in a particular execution plan. So here, for example, there is a condition to the flights table, and there was a condition to the flight date. And based on that condition, ClickHouse was able to filter out, extract 540 granules out of 24,000. So it means that particular, like that granule, the last line here on the screen, that means that the condition by the flight date, it used to work well. While the conditions, there was no conditions by the partition or min-max. It's two forms of the same partition key lookup. Like there was no condition by the partition key, so it was reading based on partition key. It would be doing the full scan, and based on primary key, it was able to reduce the number of granules to it, while it was still reading 35 parts out of 35. Also, it can be interesting to look on explain estimate. Explain estimate allows you to see not the conditions which ClickHouse able to extract from your query, but how many rows and marks it plans to read, how many parts it plans to read. So parts is just those folders, every part stored separately, rows obviously, and marks is like by default ClickHouse groups the rows into the marks, like one mark is 8,000 rows by default. So if you have a full scan, what should you do with that? So most probably you just need to the most obvious thing is maybe just missing a where condition by the primary key. Maybe you should just add that. So you have some condition by some other fields, but you missed the condition by your primary key. So just add that. And maybe you just picked the bad order by. It's quite typical when people start using ClickHouse to just create some bad wrong order bys on primary keys. So instead of, for example, in other databases, you often do something like order by, I don't know, some unique ID. And in ClickHouse, typically the good order by looks like something like order by tenant ID, some category ID, and some event ID, something like that. And if you have the bad order by, it will hurt you like in different ways. So it's better if your order by fits your query, your typical query patterns, and this way you can avoid those full scans. Unfortunately, because it is a clustered index, it's physically stored this way. There is no way how you can alter that. If you have a problem, if you did the wrong decision with your order by initially, the only way to fix that is just recreate a table. Sometimes the complex logical expressions can be the problem. I don't know, Alexander, if you can screen share, like if you can share that link about like from the gist, or it will not work. Can be problematic.
No,
let's skip. Yeah. Okay. So sometimes very complex logical expressions like where and or like a long sequence of those things then quite often can be rewritten into a form of where field in, or it can be the like just simpler expressions, just way work simpler, way work faster, way work better. So it's especially quite often the people use some query generators, and those query generators sometimes we're not aware of how ClickHouse prefer to get those conditions, and maybe we can just share that link into the chat. So just like there are two different queries which execute the same, which do exactly the same, but they're like 8 times difference, because in one case there is a good form of expression for ClickHouse, and another way it's very bad. So how you use the simpler things you do, the better they work. And sometimes you can use also, like sometimes people use some very complex. Yeah, by the way, Alexander, you screen sharing just the slide, and we see some pop up. Yeah. Yeah, and sometimes it also be the problem with the sorry, with non-monotonic functions. And so, for example, if you use some keys by the hash ClickHouse, it's not transparent for ClickHouse. Only monotonic functions were transparent for index analyzers. In that case, you just need to use the exact expression you used in the primary key. For monotonic functions, it is transparent, so you don't need to do that. Sometimes it is not a full scan, but still reads a lot of data. It could be happening because of different problems. First of all, just an amount of data could be so big. It's also very typical for ClickHouse, and it's like even after using all the indexes and so on, the amount of data is still very huge. If it's and you need to run that query very often, that's the obvious sign that you need to pre-aggregate data. So you just need to use either projections, either pre-aggregation, something like that. It will help you to gain the speed of that query. Sometimes the reading of columns is not efficient. So because ClickHouse is a columnar database, it can, for example, it can use different strategies of executing the same query. It can use first run condition one column, and after that read the rest of the columns, or it can read all the columns all together and apply the conditions on the fly. Also, it's quite typical that like when people start to use ClickHouse, like actually the good people who knows how to write like really pretty nice reading, easy to maintain SQL queries, we use like common table expressions a lot. But those common table expressions, they are not cached inside ClickHouse. So if you reference the same common table expressions many times, it will run that many times. So it means that if you yeah. And here is some example of about the pre-var. So usually, if you just use that normal logic, you can just explain that in a way like, okay, we're just reading all the columns all together, and filtering out everything which is not matching our expression. Well, pre-var logic is different. It is first reading one column and finding ranges of data for which will be used to read the rest of the columns. And if the first column one is small and nice to read and is selective, then that strategy is much better than the first one. Fortunately, ClickHouse have that optimization enabled by default. And in recent versions, it is really much smarter. So it tries to push all the conditions into pre-var automatically and execute them in stages. So like a waterfall, like applying first condition to first column, read the subrange of the second column. After that, read the subrange of a third column, and so on. So it is like very, very smart way of doing that. But sometimes that strategy, like even in newer versions, can misbehave. In that case, you should be aware that you can just write the pre-var conditions automatically, explicitly. So in that case, those optimizers will be disabled, or you can just toggle those flags to disable that by hand. Other reasons why the reads can be slow is obviously the slow disk. This can be also saturated by some other loads. It can be the backup, some mutations, merges, and so on. Sometimes it could be the S3 is just slow. There is some bigger latencies with S3. Typically, it forces you to add some caches and so on. And sometimes the people can just, while looking for a best compression, they can find too good compression algorithms, which indeed that will compress the data the best way. But once you think about the compression, you should also think about the speed of compression and decompression. So, for example, ZSTD with levels more than 3, it is usually no go for the production. So it's really, really slow. In general, just prefer simple things. It's very, very like that KISS principle here in ClickHouse is also makes sense. So just keep it simple. And usually if you have a simple query, ClickHouse is able to apply all the optimizers. It can do all needed stuff. But the more complex thing you do, like the more complex conditions you create and so on, or the more complex schema you have, it can be a reason of some really hard to nail down problems. Also, learn ClickHouse ways. So there are like in Perl, whereas in Perl there is a famous motto, like there is more than one way to do that. In ClickHouse and in SQL world in general, there are also like you can achieve the same results by doing, I don't know, sometimes by doing the group by, sometimes by doing, I don't know, like order by limit, or you can do like there are different ways of achieving the same result. Some of them are better, some of them are worse. Just play with them and learn which way ClickHouse prefers. And also, like one important thing, that whenever you do you always actually, when you're creating the schema and the queries, you can actually make a decision what kind of calculations you will be doing on query time and what kind of calculations you'll be doing on insert time. And the more you do on the yeah, Alexander, there is some pop-up on the screen share. Yeah, this one. Yeah, so the more you do on the the more work you kept for the query time, the worse actually. Yeah, so like if you really need to do often the same work again and again, it's better to do it once at the insert time. So you'll just process that row once, you pre-calculate something, and that data will be ready to use. If you in opposite, if you do that on query time every time, it means that every your single query will do the same calculations for those millions or billions of rows. While ClickHouse is still fast, it's why the hell you should create that extra pressure there. And also important is just try to process every single row and every single column once. So for example, here some expressions can be just slower than the other. So for example, at lower UTF-8 is slower than just lower, because it needs to take into account those UTF-8 characters. So the function is slower. And you can see here that it compares with foo, which is not UTF-8. So we just can bypass that UTF-8 variant and just compare that using that faster implementation, which is just slower. Or maybe we can just normalize that column at the insert time, just lowercase everything. Sometimes people create queries like that, like on the left side. They just repeat, reprocess the same column using different expressions. And here, by looking on the column name, we can understand that actually that line which we are processing is quite expensive, like quite big. Log lines were usually big, and every time like scan it like 8 times, 6 times here, for sure is not the best option. Maybe we should prefer like scan it once, maybe with a bit more expensive regexp engine, but it will be much more efficient. The other example here is with JSONs. Like if you have a JSON in your table, people often like, okay, let's extract some subfields from that. And ClickHouse have a nice API for that, but that API will toggle reprocess that JSON several times actually. Instead of that, you can parse it once, and after that, from the parsed already data, you can extract needed subfields, like that example on the right side. So those right side things, they're just better. You can as you can imagine. Yeah, sometimes the problems can be not about the amount of data you read, but about what you do with that data. So for example, it can be like slow aggregations or small sorting. One of the way of doing, like of testing if it's really the problem here or there, you can just do the A/B test. Let's just remove the order by from the query, and we'll see how slower, how faster it will become. They can do also very similar things with group by. What are the typical problems there? One of them is like one of the typical or one of the easy optimizations. If you, it's better to do the calculations on top of the aggregate function results instead of applying that on the every row. So here actually the we've got sum 10 times column. It is the same of, you'll get the same results if you'll just do like the, if you multiply by 10 the result of summing. So it is better here. Sometimes sometimes you also can see that. So for example, in the case of dict get, and if you do the group by that, it can use two different strategies. It can either first group by the column here, like by the column before the dict get, which is cheaper, obviously, or it can do the group by, and after that apply the dict get to every group, or it can do first dict get and after that apply grouping on top of that. Obviously, the second option with when you just need to the option when you need to calculate the dict get on every row is more expensive, and that is controlled by injection. So to make that optimization happen, ClickHouse have a special flag. You can mark every dictionary if it's injective or not. That toggles that changes that behavior. Data types also matters. Like if you have very complex data types and you need to do group by them, sometimes it's better to, I don't know, like maybe you can use different columns or different types, and it can be better. Some aggregation functions are more expensive than the other. So for example, unique combined is cheaper than unique, and unique is cheaper than unique exact. That's quite simple. And there are also like more low-level things like to level a group by and so on.
Thank you, Mikhail. I will continue from here. Another possible reason of slowness of your queries is joins. So ClickHouse, of course, can do joins, but it doesn't have cost-based optimizer. So it is pretty conservative in terms of how to perform joins. Up until recently, ClickHouse could only do hash joins, and that also limits performance and limits the size of tables that could be joined. So for big tables, hash join may be quite slow. And when merge join has been introduced, there were also some issues initially with performance. Even if both sides are properly sorted, ClickHouse couldn't do it and did resorting. But first thing to ask yourself is, do you need join at all? Because joins are always expensive in ClickHouse. And there are a couple of ways to avoid them if possible. First is denormalization, which is kind of equals to insert time join. And instead of having a lot of key columns and then doing joins, you can just have values as a part of the big table. And since ClickHouse has column store, this is quite inexpensive compared to other databases. Another way to avoid join is dictionaries, which Mikhail showed in the previous slide. You may think of a dictionary as a hash map, which is always kept in RAM. Of course, there are some different ways to do dictionaries, but the most typical one is to have the dictionary, which is just stores in RAM. And that actually helps in two ways. First of all, you can consider it as a cache because the data is always here. And second, you don't need to do a join, which simplifies the processing that ClickHouse needs to do in a query time. There are multiple settings about join algorithms. ClickHouse is pretty good with defaults, but in some cases, you may need to do a little bit of experimenting and trying other algorithms. So usually it's only for bigger tables. If you need to do some very big tables, then you may look into merge, a partial merge or grace hash, so things like that. In the typical scenarios, you shouldn't be concerned about this at all. Let me show you a couple of ways how we can optimize joins, because if join is slow, you can still make it fast. On the left side here, you can see the simple query to the trip data. It is standard test data set for New York taxi rides, and it joins for the zones in order to find the top zones by the number of passengers that have been served in 2016, and the query runs in 40 milliseconds, which is pretty fast. In this query, if you think about that, ClickHouse has to do join and then do aggregation after that. So for every row that is subject to condition, it has to do a join and then do an aggregation and so on. On the right side, the query is a bit different. First, we do an aggregation on a location ID, which is very fast. And the result of this query is much lesser number of rows in a query. And after that, we're making a join. So ClickHouse has to do much smaller tables, has to join much smaller tables, and also to aggregate easier, simpler, with the simpler data types. On the left side, it has to merge, I don't know, several 100 million square rows maybe, and then aggregate on a string. And on the right side, it was aggregating on an integer and was joining on probably tens of thousands rows, which is of course faster, and you can see that the query is 4 times faster. Another example is a filter by join. Up until recently, ClickHouse couldn't do a push down properly when you have a condition on a join table. It is a little bit better now in 24.4, I guess, but still far from being optimal. And instead of using a condition on a join table, you can do a trick kind of similar to preval logic that Mikhail has shown earlier. You can filter the join table first, extract location IDs, and then use a where condition on location IDs only. This query is much faster. You can see that the query performance increased 15 times in this example, which is pretty impressive. So far, we were only talking about single queries, and even this topic almost consumed all the hour. So now we will touch base on a few other things. Distributed queries. The distributed query is much harder to optimize because you need to optimize it in 2 levels. First, you need to optimize how your local query works, and second, you need to optimize how your distributed queries work in general. And the optimization is very different on those 2 levels. When distributed query is being executed, you first need to push.
Not sure if it's me, Luz.
Can you hear me?
Yeah.
Okay.
You get back. Mm-hmm.
Okay. When distributed query gets executed, first you need to push as much processing as possible to shards. And ClickHouse actually processes the dbms subquery on a sharded manner, and everything else may go to a node initiator, which is, of course, not very efficient. So you need to be very careful about how you structure a query. Second is is using joins and in conditions if you have two distributed tables. This is be very careful with that. You can actually affect your performance. It may affect your performance 100 times if you do it in the wrong way. By default, ClickHouse doesn't allow you to do joins with two distributed tables, but users tend to overwrite this and get into troubles. Another very important thing to think about is data locality, how your data is distributed amongst shards, because in many cases, it allows you to do much more efficient aggregation. For example, you may put all the data about certain user to a single shard, and if you calculate uniques, for example, then you may calculate uniques independently on every shard and then do the summation, which will be much more efficient compared to the distribution when the data about the particular user is randomly spread across multiple shards. And when you calculate unique, you need to do it, you need to build hash maps. ClickHouse will have to build hash maps on every shard and then do a merge of those hash maps, which takes much more resources and time. In 24.3, there is a new feature coming. Mikhail, could you get a little bit explanation of that?
Yeah, so that is a very long process to get to that moment of time. So it's like a really huge increment. So it allows you. It's really big, like as a picture shows, it's just like opening the door to really like nice shiny future, hopefully. So it is really changing, like kind of revolutionary changing of the way how ClickHouse works with queries internally. So before that, it was mostly working on the level of the syntax tree, and now it have like much more like higher level view on the queries, and that allows to make possible a lot of cool optimizations. Like in the future, it could be like even like cost optimizer for joins can pop up based on that. And it allows to sort out tons of different like small problems with the ClickHouse alias syntax, which is not standard, which is handy, but which is not standard according to basic SQL standards. In like long story short, like on 24.3, the joins should, like if you had some problems with joins or some problems which is like some complex problems with the aliases, most probably it will be solved by upgrading to 24.3. But also that is a new stuff. It is still in its younger, like in its early stages, like it's already ready for production, but it is still, you can still face some small problems here. So if you're doing upgrade to 24.3, please start using that analyzer first. Please see how your complex queries will start making better, and if it will be misbehaving, you can always turn it off.
Yeah, so you will see the behavior change, of course, and this is the reason, the analyzer. So we will take 15 more minutes. Sorry about that, but we have 2 more topics to discuss. First is RAM and caches. So ClickHouse uses a lot of RAM when it's runs, and it has a lot of internal caches, and it's important to understand how it works. On this picture, you can see some of the caches that are used when the queries are running, or where the data is being inserted, or when the data is being merged. We're mostly interested in selects, and if you take it from the bottom up, there are multiple caches involved. All space cache comes first, and then it just caches the raw data, and that's it. Then there is an index cache and mark cache, which caches ClickHouse internal metadata about how the data is stored on the in a file system, and index cache and mark cache is used in order to locate the binary data in the most efficient way. There is also uncompressed block cache, which is pretty small, and it's not very useful. And there is a query cache that allows you to cache query results. And inside the select as well, select itself, there are some other caches that we're not going to discuss in many details, but still it's worth mentioning. If you use an object storage, then always use this cache, because it will not only help with performance, but also will reduce your costs, because using object storage also incurs some not very obvious costs about API calls to S3, etc. You can see some better dive into caches in our blog, but here we will just show a couple of examples. First of all, page cache and why it's important. So always try to run ClickHouse with more RAM that is needed for your queries, because extra RAM, it's not lost, it's not unused, it will be used by Linux page cache. You can always see effect of this page cache if you turn it off, and you can do it with the settings on the right side, min bytes to use direct IO equals 1. It kind of disables the page cache completely. And if you try the query on GitHub database, which is one of ClickHouse examples, you can see that normally this type of query will probably run for 7 seconds. It's pretty heavy query. It needs to parse title column and find all occurrence of cache substring. But if we disable page cache, it's much slower, because ClickHouse has to actually read it from the storage, not from the RAM. So in this case, it was 3 times slower. In many cases, you can see even more dramatic difference. There are always statistics, and you need to try to keep this page cache utilization as high as possible. Another important cache is the cache which is used during query execution, mark cache and index cache. So if I can remind you how ClickHouse finds the data during in a query time, first it uses the sparse index, which allows ClickHouse to select certain granules of the data. And then for every granula, there is a special mark file which tells ClickHouse how to find the binary data for a particular column. If this data wouldn't be cached, and then ClickHouse would do a lot of I/O operations even before starting to read the data itself. So that's why it tries to cache it. Index cache is always in RAM. Mark cache is usually in RAM. So there is some limit in ClickHouse itself, but usually a mark cache is in RAM. And you can check your mark cache utilization using system events. So in a well-tuned system, it should be 99% of cache hit. If it is 80% or 50%, then your queries are not efficient, and you can speed it up, just making sure that there is enough RAM for mark cache. Query cache, this is pretty new. Probably it has been added to ClickHouse a year ago, and it allows you to cache query results. So in this example, if you run the first query for the first time, it will probably take a few seconds. But on a second time, it will only take 1 millisecond. This is because the results can be taken from the query cache. ClickHouse has some default configuration with default size and how many entries you can keep in the cache, but you can also tune it on a profile level or on a session level using parameters. Some of them are shown here, like TTL, which is by default 60 seconds, or how many times the query should run in order to be cached, or how long the query needs to be executed in order to be cached. So these are worth being tuned, and you can just make your queries much faster if you have a lot of repetitive queries. So summary about the memory. It's always more memory is better. So if the memory is unused, it just goes to page cache. Never use swap with ClickHouse, because ClickHouse will just start sluggish. Usually we just recommend disabling swap completely. There are some settings in ClickHouse that will allow you to avoid OOM killer, but ClickHouse is not very good in memory tricking in general. So it's still possible that some very memory intensive query or multiple memory intensive query will kill the server. But ClickHouse developers tries their best to decrease this probability. Our last topic for today is optimization for concurrency. And Mikhail, if you don't mind, please cover it.
Yeah, sure. Yeah, so sometimes the problem is not the particular query, but the amount of queries. Like it is not super typical load for all app databases, for analytical databases, but sometimes people still use ClickHouse for that. Few notes here, like having too much concurrent queries usually is not the best idea, because it creates, like ClickHouse creates really the threads for every query execution. So it will end up with kind of fork bomb. So it will have a lot of threads working in the system, a lot of context switches, big clock contention, and so on. So performance will be suboptimal for sure. So don't, like, just having fewer queries running simultaneously is better. If you have a situation, then you have a really high amount of queries. It means that every single query should be really fast and should be really don't use too much resources, because otherwise it will interfere with the other queries. It will have like the negative impact on the others. But it's quite funny that for that use cases, it's quite often that you want to enable the queuing of a query. So instead of increasing the number of concurrent queries which can be executed simultaneously, you can just enable the queuing of them. So not adding more cache desks to your to your fast food, but just having like set those guys who want to get the answers in the queue. So that like helps to survive your system, because if you have too many of those execution slots, it usually creates too much pain. Also, if you have like too many, like a lot of concurrent queries, usually you need to be very careful with threads. Like ClickHouse by default will allow a single query to use as many threads as you have the cores in your system. So if you have like 16 cores CPUs, it will have like your single query will start 16 threads. And obviously with scaling up number of queries, the number of threads start being like crazy. So if you really have a load with small fast queries, usually need to decrease that max threads even to 1, or use another feature which is called concurrent threads soft limit. You can check that in documentation. I'll not stop there. Also about load balancing. So if you need to deal with a lot of concurrent queries, usually you need to have more replicas, more than one for sure, most probably 2, 3, 5, whatever. And just using the distributed queries, it can be painful in those scenarios. So instead of distributed tables, you may prefer to have smart sharding, smart load balancing on your backend, on your scripts, because if you do the distributed query, actually your single query get transformed into 2 queries. One query is distributed one, another one is the local one, at least. And if you have more shards involved, then it will be more. And if you have like really thousands of those queries per second, then every doubling of those is a problem. Yeah, let's go to next slide. Yeah, so maybe instead of like you need to really step back and think maybe there is some ways how you can avoid those loads. It's not super ClickHouse way of doing the things. So maybe you can just do some caching on the replication side. Maybe you can just plan your background jobs carefully, just shift them in time, like spread them in time more equally. Just not have like all of them happening together. And you can, like, if you still have that, if you have that situation, you are obligated to just review and refine your queries. Like every time, every change needs to be really carefully checked, benchmarked, and just don't blindly add anything to that balanced system. And if you have the situations like that, you need also to have some plan B, because what if you, okay, I'm tuned my system for 100,000 queries, but next day I'll get like 200,000 queries. So what will happen? So I cannot just tune for, I need to have some plan B. It could be throttling, it could be, I don't know, showing some cache data, it could be disabling some jobs, or just this dynamic cluster rescaling. So some plan B should be prepared. Also, with those very high QPS scenarios, the query overhead can work against you. So normally when you execute when the query is executed inside ClickHouse, you can imagine that it contains from several stages. Like first, we just need to parse that, like to accept that query, log that we started executing that. After that, like start parsing that. After that, analyze the where conditions, indexes, prepare the pipeline, run the optimizers, and after that, the actual execution of that query, of that pipeline. Usually for big queries, that execution of pipeline is the biggest part of that. And after that, after it's finished, you get your results, the query get finished, you're logging the query end, finishing everything, closing the buffers and so on, and you're happy. But with very fast and cheap queries, sometimes that execution of pipeline can be very small compared to the other phases. So if your query runs, I don't know, like one millisecond on every run, or I don't know, 1 microsecond or something like that, most probably the execution of the pipeline is really small percent of that. So in that case, you may want to optimize the other things. So maybe if you really have like high QPS, like you need to first simplify the queries as much as you can, because parsing of that is also taking some time. Maybe you just need to avoid the logging of those queries at all. So just skip that query log thing at the beginning, at the end. So just, or make it more, make it not happen every time, but I don't know, for 10% of the cases, and reduce the logging. So all those steps, they can help to reduce that overhead. Also, you may think like if some optimizers are not needed because they need to scan your query, and if you see that sometimes if a query is very simple, nothing to optimize there, just disabling those optimizers can be also give some improvement.
Thank you, Mikhail. So basically, this is the endless topic. So we could continue for 2 more hours with some examples and from our experience, how to optimize queries. And typically, this is what our engineers do every day for our customers. But unfortunately, we don't have so much time. We will probably continue this performance series in our next webinars. Before then, check ClickHouse documentation, has a lot of insights on different settings and things. We often publish technical articles in Altinity blog that are also focused on performance and have some hints that can help you with optimization. Check Altinity knowledge base. Some of examples, especially for finding slow queries, for comparing queries before and after, you can find those queries in Altinity knowledge base, as well as many other interesting things that you can find from ClickHouse system tables. And check our blogs and other things. You can also find us on Slack. There is ClickHouse Slack and Altinity workspace in Slack. And if you have any questions, don't hesitate to ask. And finally, if you want kind of more interactive session, we have Altinity ClickHouse training, which is focused on more advanced topics about ClickHouse administration, but also can cover tuning and performance optimization. If you are not sure if ClickHouse is for you, or you have problem that you want to solve right now, just feel free to sign up for a free consultation. We do provide free consultations, and you can talk to Mikhail or to some other engineers, and they can dig into your use case and probably help with performance optimization during this free consultation call. That's it for today. Sorry for taking too long, but this is a very important and interesting topic, so we couldn't just keep ourselves in time constraints. Sorry about that.
Thank you guys for joining.
Yeah, if you have any questions, just contact us by emails, and we will distribute all materials, and we'll be happy to answer. Thank you. Goodbye.
Bye, guys.